So the following pseudocode is executed on the scores table. What is the value A represent at the end of execution? And this is a multiple select question. So what we'll do is we will paste this code block in another window, right? So we want to find what the variable A represents. Let's go line by line. The first line we have an empty list S to begin with, and then we are iterating through the rows in table 1, right? So whenever we see a particular row having city, town, Madurai, or the gender being female, then we append this particular elements or this particular rows sequence number to the list S, right? So that's what is happening, and we keep doing this until we exhaust all the rows in table 1, and finally we are calculating the length of S. Length of S is nothing but the number of elements in the list S, and we are storing the result in the variable A. Okay, so to analyze what's happening in the list S, we create the following table, right? So this table has two rows and two columns. The rows represent gender and the columns represent the city Madurai, right? So the first cell in this table gives us the number of males from Madurai, and it's represented as M, capital M. The second cell here represents the number of males not from Madurai. This cell represents the number of females from Madurai, and finally this particular cell represents the number of females not from Madurai, right? So these are the four variables involved, right? So the expression we are interested in is this particular one that we have written here. So how did we get that? Let's go back to the pseudocode. So if you notice, we are interested in all those rows which have the city town Madurai or gender female, right? So that means we are interested in this entire column. All those who are Madurai, all those who are from Madurai are of interest to us, and also all those students who are females, that also we need to include, right? That is nothing but the sum of these three cells, right? So M capital M plus F capital M plus F capital N. That is exactly what we have written here. Now we go back to the answer, right? So we see that we are given the options in the form of text, right? So how do we arrive at this? It's just a matter of grouping this expression appropriately. So if you group it in this way, by clubbing all the Madurais together, we get the total number of students plus the total number of students from Madurai, and we add to that the number of females not from Madurai. So which option does this correspond to? So this last option, right? So number of students from Madurai plus number of female students not from Madurai. That is the last option. The second way of grouping is as follows. We group all females together. So the second option is nothing but the number of female students plus the number of male students from Madurai. As you can see, number of male students from Madurai and number of female students. So for the last option, what we do is we add and subtract the number of females from Madurai. So that gives us this nice grouping. We can group all the Madurais together and all the females together. So this is nothing but the number of students from Madurai. You add to that the number of females in total, and you subtract the number of females from Madurai. That's what this third option corresponds to. Another way of understanding this is in the number of female students, some of them will be from Madurai, and in the number of students from Madurai, some of them will be female. So we are double counting that particular quantity, so we subtract it once. That ends the solution to this problem. So we have two lists with us, top math and top physics, right? So these are lists of cards that have mathematics marks and physics marks greater than 80 respectively, right? Now each element in both lists, right, is a record, and the fields are the same as the ones that we used in the scores table. So we are asked to find the value of the list, sum list, right, what it represents at the end of execution of this particular pseudocode. So what we will do is we will paste this pseudocode in a separate window. Okay, now we need to find what this variable sum list represents at the end of execution. So let's go through the code line by line. So sum list is first initialized as an empty list, and then we have a nested for each. The outer loop goes through the elements in the list top math, and the inner loop goes through the elements in the list top physics. And inside this nested iteration, what we have is there is a filter. So there is an if condition that is checking if the card X in top math and card Y in top physics, are they both pointing to the same row in the table, or do they correspond to the same student? That's what this first part of the if condition is checking. And the second part of the if condition is checking whether this particular student has obtained more than 80 in chemistry, right? And since there is an and here, we need both conditions to be true. Only then this statement inside the if will be executed. And what that statement is doing is it's appending the name of the student to sum list, right? Okay, so let's take an example. So top math has these elements m1, m2, m3, m4, and top physics, let's say, has these 6 elements, right? So these are 6 students who have scored greater than 80 and in physics, and there are 4 students who have scored greater than 80 in maths. Entire if condition evaluates to true only if these two individual conditions evaluate to true. The first condition is that the elements that we are considering should be common to the two lists, right? The second condition is that the chemistry mark of the student who is common to the two lists, that particular student's chemistry mark should be greater than 80, right? And we already know that the mathematics and physics mark of this particular student is more than 80. If we add that fact to this fact here, that the chemistry mark is greater than 80, what we get is that the student X has scored above 80 in all 3 subjects, right? Only then will we append this student to the list, sum list. So let's come again. So when are we going to add an element X to sum list? Only when this particular element, or in this case the element is nothing but a student, only if the student is present in both these lists, right? So the student X that we are adding here should be present in top math as well as top physics. Not only that, that particular student should have also scored above 80 in chemistry, right? So that is what we mean here. So this entire if condition will evaluate to true only if the element in question is common to both these lists and the chemistry mark of this student is greater than 80, right? By element we mean nothing but a card, and a card corresponds to some student in the table, right? Or some student in the class. Okay, so if you put these two conditions together, what we get is that sum list contains all those students who have scored greater than 80 in all 3 subjects. This is exactly what is given here, right? So this is the correct answer. So sum list represents, or it stores, the names of students who have scored above 80 in all 3 subjects. That ends the solution to this question. So in this problem, we have the notion of similar sentences given to us. Okay, so we say that 2 sentences are similar if they have the same number of words to begin with. Not only that, the ith word in the first sentence should have the same part of speech as the ith word in the second sentence. So if both these conditions are satisfied, then we call 2 sentences similar. So the question here is asking us to complete this code here. So what is this code doing? It's a procedure, and it accepts 2 lists as input, right? So these two lists correspond to the sentences A and B, right? And it is checking if the two sentences A and B are similar, right? So what do these two lists represent? They contain the part of speech of the words in these two sentences. So A list will be a sequence of parts of speech of words in sentence A, and B list will be the sequence of parts of part of speech of words in sentence B. Okay, and we are now checking if sentences A and B are similar according to this notion of similarity that has been given to us. So let's first copy this code into another window, right? So as we stated, conditions for similarity is first, two sentences should have the same length, and the POS. So POS mean part of speech. The corresponding words in these two sentences must be the same, right? So the code block that has already been given to us, it is checking if the length of A list and B list are the same or not. So if they are not the same, right, then there is no point in continuing, right? Because the first condition is wrong, right? So they are not of the same length. So the whole idea of similarity breaks down. Now remember that when we say that they are similar, both these conditions should be satisfied. In some sense, this is like an and, right? This should be true. So should this second statement, right? So let's take an example of two sentences having these parts of speech, right? So if you notice, they are of different lengths, right? So let's go through the process that will happen here. So we'll enter is similar, A list, B list, and in this line we'll be checking this condition, right? So length of A list is nothing but 4, length of B list is nothing but 5, 4 not equal to 5, so we'll return false. And here is some important point that you must all remember, that is the moment a procedure returns something, right, it can be false or it can be true or whatever it is, the moment a procedure returns a value, we have to exit the procedure, right? So I repeat this, this is a very important point. The moment a procedure returns a value, then that means the procedure terminates, right? So the moment the procedure terminates, then we have to exit from it. So there is no point in considering all these other lines of code even though they are there after this particular line has been executed. So the moment this line is executed, then that means the procedure has ended. Whenever you see a return statement get executed, you have to exit out of the procedure, right? Even though this return statement may not come at the end of the procedure, right? That is not an issue. The moment you execute it, that means the procedure has terminated and you don't need to consider anything that comes below it. Okay, so we'll consider another example. Now we will do this example with the correct code block, right? So I'll just push this down. So this is the correct code block that we have to fill in. And now let's take an example where the two sentences are actually similar. That is, they have the same length and the parts of speech of corresponding words are also the same. And let's see what is actually happening. Right? So this particular code block is the one that has to go in here. So before that, let's see what we do here. We are initializing a new list called C list that is equal to B list. Now why we do this will become clear in a short while, right? But so far what we have is we have three lists, the two original lists that we started off with, A list and B list, and now a third list that we call C list, which is being initialized to this particular B list, right? So this code block that you're seeing here is the one that has to be filled in. Let's see why this is the correct one and why this is actually what we expect. Okay, So before we start, one thing becomes clear. How do we find, how do we check for similarity? The way we check for similarity is we go through each element in A list and see if the corresponding element in B list is the same, right? So that is exactly what's happening here. We iterate through each element in A list using a for each. So for each x in A list, so that's the main action that we are doing here. Now we are checking if the current element x in A list, whether it's equal or not equal to the first element in C list, right? So we are checking if they are unequal, and if it is true, if the two are unequal, then we are returning false. Okay, and then we, outside the if, we have C list equal to the rest of the elements in C list by ignoring the first one. Now all this may seem very confusing, so what we'll do is we'll go with an example. So before we enter the for each loop, x is nothing, right? So x is no meaning before we start the for each. C list, as you remember, is being initialized with the value that is there in B list. So C list will be the same as B list before we start the for each. Okay, and first of C list will be nothing but the first element in C list, which is now. Okay, now we start the iteration. So we take up the first element in A list, that is noun, right? C list remains the same. We are checking if x is not equal to first of C list. First of C list is nothing but noun. Noun and noun, they are equal. So this condition will evaluate to false. So we directly jump to this line. What is this line doing? It's updating C list to be rest of C list, right? So just watch closely. So rest of C list. So this is C list now. Rest of C list is nothing but everything except the first element. So we ignore the first and then select the rest, right? So that is what happens here. So this is the correct new value of C list. Okay, and we go back and pick up the next element x in A list, that is verb. So in the second step of the iteration we have taken up verb. Now notice that the value of C list has changed, right? So in the last step of the earlier iteration we had done C list to be rest of C list. So C list currently stores these three elements. Now once again we are checking if x is not equal to first of C list. Again it's this if condition evaluates to false. Now we go and update C list. So C list will now have only these two elements. We go back and we keep repeating this procedure until the last element x in A list, which is adjective. Again, adjective is equal to adjective, so this condition will evaluate to false. Okay, and then we'll come out of this for each loop. And when we come out of this for each loop, there is nothing else to do, right? We have just checked the fact that every element in A list is equal to the corresponding element in B list, right? And therefore we return true. Okay, so let's take up another example where the two sentences are not similar and see what happens. So notice that the dissimilarity creeps in at the third word. So third word in B list is an article, whereas the third word in A list is an adverb. All others are same as before. X stores nothing before the for each, and this is a this is a this is C list, and now we start the iteration. So we select the first word in A list. Its part of speech is, sorry, we select the first element in A list, and that's noun. First of C list is also noun, so no issue. We'll go and update C list. Again, in step 2 also we don't have a problem. In step 3, however, we have a problem. So the element x is adverb, right? Adverb, but the first of C list here is article. Okay, and since they are not equal, this particular line, since they are not equal, this particular line is going to evaluate to true and we will return false. Right now, notice even though we have one more iteration or one more step remaining in for each that is not being executed, that is because we have executed a return statement. And the moment we execute a return statement, we will exit from the procedure. The return, wherever it's executed, is like a hard stop. All right. So this is something that's very important to remember. Now going back, why was C list initialized to B list? Now we could have done all these things using B list itself. So the reason we don't do that, the reason we have a new list called C list and do the computation with that is we don't want to erase the value of B list, right? So that's a side effect. So if you had done the whole computation with B list instead of C list, what would have happened is that the value of B list would have changed, and that is an unnecessary side effect. We want A list and B list to remain the same, right? And finally, how do you actually come to this solution? How do you arrive at the solution? What we have shown so far is we have just verified that this is true. Now, how do you, in the first place, come across this particular solution? So, for that, we need to notice that whenever we are checking for the equality of corresponding elements, all the elements that come before are of no interest to us. For example, we want to check if the third element in A list is the same as the third element in B list. When we want to do that, the first two elements in A list no longer matter to us. The same, the first two elements in B list no longer matter to us. Only three and all the elements from three matter to us, right? So that is the intuition for this rest statement here. Every time we process a particular element in B list, in this case C list, because we have already copied the elements of B list to C list. So every time you process an element in C list, we reset or we update C list to rest of C list because you no longer need the particular element that you just processed. Okay, so in this way you keep cutting down the length of C list so that the first of C list, right, at every step of the iteration will correspond to the corresponding element in A list, which is X, right? If this seems a bit confusing, please pause and think about it for a while. I'm sure you will arrive at the answer. And that ends the solution to this question. So in this question, we have been given a list called days. Okay, so the elements in this list are going to be the sequence of entries contained in the column day in the trains data set. All right, so and we have a passenger named Madhuram. So he has this peculiar habit of eating exactly one sweet at midnight whenever he's traveling on a train, right? And we also know that Madhuram boards the train at the starting station and only gets down at the ending station, right? So he travels on this train for the entire duration. So wherever it starts until it stops at the last station, Madhuram is on the train. So how many midnight sweets does he consume during the course of his journey? So that is a question that is there in front of us. So what we'll do is let us take some random train in the train's data set, right? And assume that it has the following departure and arrival times. Okay, so it departs from the starting station at 7:40 a.m. Okay, so the corresponding arrival time for that station will be none, right? Because it departs. There is no point in having any arrival time there. Okay, this corresponds to day one, right? So the train has just started. So on whichever day it has started, that will correspond to day one of the train's journey. Now it arrives at the next station. This is the first stop. So it arrives at the station at 10:44 a.m. Okay, it waits there for 5 minutes and then departs at 10:49. Okay, so the entry again will be 1 because we are still in the same day. 7:40 in the morning it started, at 10:44 it has a stop, so we are still in the same day. After 10:49 it departs, so at 10:49 it departs and reaches the next station at 14:56, right? This is nothing but 2:56 p.m. So it makes a stop there. We are still in the same day. Okay, no change. And then it leaves at 3 o'clock, 3 p.m. again. The next stop is at 8:45. So we are still in the same day, mind you. And it leaves at 8:56. And finally, what is happening here is the next stop is at 12:50 early morning, right? So this is 12:50 a.m. So now we have moved to day 2, right? So this is day 2 of the journey because we have already crossed midnight, right? So now if you notice, Madhuram would have taken one sweet, right? So he would have treated himself to one sweet whenever this transition happened from day 1 to day 2. Then finally what we can see is at 12:55 a.m. early morning it leaves and arrives at the last or the ending station at 6:25 a.m. There is no departure time because this is the last station and it stops there. And this is still day 2, right? So how many sweets has Madhuram consumed? He has consumed exactly one sweet. That is because there was only one transition involved. From day 1 we went to day 2, and this transition from day 1 to day 2 happens at midnight. Okay, so what we see is that when there are 2 days of journey involved, there is exactly one night. All right, so whenever there are n days, you have n minus 1 nights involved. So just to understand this better, consider this example. So this is the list days. There is one transition here, 1 to 2. So Madhuram would have taken one sweet here, 2 to 3, one more sweet, 3 to 4, one more sweet, and then when 4 to 5 happens, another sweet. So if you add up, it's 1, 2, 3, and 4. So 4 nights involved, so there are 4 sweets. There are 5 days, so there are 4 nights, right? So if there are n days, there are n minus 1 nights. So let's go back to the options given to us. So they're all in terms of some functions or some operations on lists. So how do we tie these things together? So we need something like n minus 1. How do we tie these two together? So n is nothing but the number of days. How do we get the number of days? It's nothing but the last element in the list days, right? So the number of days is nothing but the last element in the list days. So that is what we have. So we need to subtract 1 from it, right? Because the number of nights will be 1 less than the number of days of travel. So we need last of days minus 1. Okay, so that is this option here. All right, so that works. But we have one more option. What is that? That is last of days minus first of days. Now, why is that correct? Now, notice that first of days is always equal to 1, right? So this expression always evaluates to true. Every train starts on the first day, right? So whatever day it starts, that is going to be called day 1. So the first element in days is always going to be 1, and that is why these two expressions are equivalent, right? Therefore we have two solutions to this problem: last of days minus 1, last of days minus first of days. That ends the solution to this problem. So we have train list and non-empty list. So it contains information about trains associated with a station. All right, so each element in train list is itself a list. So it's a list of running days for a train. So the example that's given to us is this particular list here. So there are two trains associated with some station, and the first element here corresponds to the first train associated with that station, and it runs on these 2 days, Monday and Wednesday. There is another station. It has exactly one running day. It only runs on a Saturday. That is, this station has to serve the train only on a Saturday, whereas for this particular train, the station has to serve it on a Monday and a Wednesday, right? So what do we mean by running days for a train? So it's nothing but the days when this train will visit this particular station. So for example, the train that we are considering here will visit the station in consideration on a Monday and a Wednesday. The second train that the station serves, that particular train will visit this station on a Saturday. Okay. We are also given this additional information that all the elements of train list are non-empty. Right? That is, they'll have at least one element in them, and this train list itself is non-empty. That means if whatever station we are considering, it will have at least one train. Right? That is, it will be serving at least one train. Okay. Now let's go back to another window to try and understand the pseudocode. So the names of variables in the first line are very suggestive. So M stands for Monday, TU for Tuesday, and so on. So there are 7 variables that stand for the 7 days of the week. And then we have a nested iteration. We have a for each. It goes through each element in train list. Now just to remind you, each element in train list corresponds to another list, right? It corresponds to a train. It's nothing but the list of running days for a train. So X is itself a list, right? And X is nothing but a list of running days for a train. Now we are going through each element in X, right? Each element in X, we call that Y. Again, a for each, right? We use a for each to go through each element Y in the list X. Y will be nothing but one of the days of the week. It will either be a Monday, Tuesday, Wednesday, and so on, right? And what we are doing inside this nested iteration is that if the day is a Monday, then we update the variable M, which corresponds to a Monday, to 1. If the day is a Tuesday, then we update the corresponding variable TU to 1, right? And notice one interesting thing. The moment you update any of these variables to 1, their state never changes. That particular variable state never changes, right? So they're all 0 to begin with. And the moment you update any one of them to 1, right, they remain 1 for the rest of their lives. Okay. So this is very important. And notice that this is not incrementation. We are not incrementing any of these variables. We are just assigning them the value 1 if this particular day matches. If y is equal to w, then we set w to 1. That's it. Okay. So now what are we asked in the question? We are asked a few things. So let's go to the question. So we are asked what the variable somewhere stores at the end of execution of this particular pseudocode. Right. So this pseudocode assumes that it has already been executed, right? And we have some values for these 7 variables now. They are either 0 or 1, nothing else. Now what does this variable somewhere store, right? What is somewhere here? What we are doing is we are subtracting the sum of all the 7 variables from 7. Okay, we need to understand what this means. In order to do that, let's take an example. So let's take a station that is serving 3 trains. So you can see there are 3 elements. So this particular station has a list of 3 trains associated with it. And the first train has 2 running days, Monday and Thursday. The other 2 trains have 1 running day, Tuesday and Wednesday respectively. Right? So now what's happening? We are doing a for each X, right? So for each X in train list. Okay, so the first element X here will be the list containing Monday, Thursday. There we have a for each Y in X. What will this do? This will go through Monday and then Thursday. Now since Monday matches Y, right, or Y matches Monday, M is set to 1, small m is set to 1, right? That's exactly what's happening here. And for each Y, right, so we have the next element Y in X, that is Thursday. Since Y double equal to TH or Thursday, the Thursday variable will be updated to 1, right? Now we go back to the outer loop for each X in train list. The next element in train list is this list, so we'll take that up. Now for each Y in X, we have only one element, so only that we need to process. the variable Tuesday will be updated to 1 here, right? And then finally we come back and we take up the element X. All right, so this should be in bold. Okay, and we again have only one element Y, so we check all the if conditions and exactly one of them is going to get executed, and that is this. So W will be set to 1, right? And now there are no more elements to be examined in train list. All right, so the final collection of variables and their values is this. So these are the 7 variables, and Monday to Thursday all have the value 1, the rest have 0. So if you notice, Monday, Thursday, Tuesday, Wednesday, they all have the value 1, right? The other 3 variables have not been disturbed because we didn't find any of them in the list that was given to us. Now we compute somewhere that is nothing but 7 minus the sum of all these 7 values, that turns out to be 3. Now what does this 3 correspond to? This 3 is actually nothing but those days on which the station was not busy, right? Those days in which no train stopped at that particular station, right? So here, if you see, these days are Friday, Saturday, and Sunday. These are the days when the station was not serving any train. What does the variable somewhere represent? It's nothing but the number of days in a week when no train visits the station. All right. So let's go to the last question in last subpart in this question. So which of the following is an accurate bound for somewhere? So now we see that somewhere can be 0. When will that happen? When you have a station that is serving all for all 7 days, that is serving trains for all 7 days, you will have somewhere to be 0 because all 7 variables will have the value 1, right? So somewhere can certainly be 0, and clearly it cannot be less than 0 because you have sum of 7 variables which are either 0 or 1. So the minimum value of somewhere is 0 and it can assume the value 0, right? Now we claim that somewhere can never be 7. Now when will somewhere be 7? It will be 7 when all these 7 variables, right? It will be 0 when all these 7 variables are 0. When will all these 7 variables be 0? When a particular station is free on all days, right? That means no train visits a station. This particular station, if for that station all these 7 variables have to be 0, then it is free on all 7 days. It is not at all busy. This means that the train list will be empty, right? Only in that case will somewhere take the value 7, right? But this can never happen because in our question we have the condition that train list is a non-empty list, and also we have the condition that all elements in train list are non-empty, right? So at least one of these 7 variables will have to be 1 at the end of execution of the code given here. So at least one of them will be 1. So we arrive at the answer that somewhere can be 0 but it can never be 7, and naturally it cannot be more than 7. So 0 less than or equal to somewhere less than 7 is the right bound for somewhere, and that ends the solution to this question.